Welcome to Spring LIB.
So when we have electrolysis problems, we always need to find the moles of electrons that are being transferred. That's always going to be key to getting to the solution. So if you don't have that, you can't arrive at the solution. So we need to find the change in oxidation state from bismuth at the start of the process to the end. So first, bismuth is present in this molecule BiO+, and then it's changing to bismuth solid, which is going to have an oxidation state of 0. So we need to find the oxidation state of bismuth. From our oxidation state rules, oxygen is always -2. The total charge of this ion is +1. So now we can solve for what the oxidation state of bismuth is going to be, which is going to be, it's +3. So that means that 3 electrons are needed to reduce to pure bismuth. So now we can move from the mass of this BiO plus all the way to how much time that's going to take to get there. So we can move from mass, we use our molar mass to find the number of moles. We use the mole ratio of bismuth to this bismuth oxide ion to give us moles of bismuth. We can then get into moles of electrons from the mole ratio. And then use Faraday's constant to give us the charge, and then use current equals charge over time to give us the amount of time needed to do this reduction reaction as according to the mass given. So if we do this as kind of one conversion factor for as long as we can, 10 grams of bismuth, here's the molar mass, 3 moles of electrons for every 1 mole of bismuth. Now, the thing is, the mole ratio of bismuth to BiO plus is 1:1, so I didn't write it in there, but you could. It would be fine. It would actually be even more thorough. Then we've got for every 1 mole of electrons, there's 96,045 coulombs. So this is the total charge that is being transferred to reduce this bismuth oxide into pure bismuth solid. And so now, if this is the charge, I can rearrange current equals charge over time to give us the amount of time. And so this is 25 amps, which is 25 coulombs per second. So if I rearrange and solve for t, I end up with 514 seconds, which is 8.6 minutes.